The concrete industry is focused on reducing its emissions, with the aim to produce net zero concrete by 2050, but have been making efforts to improve environmental performance and implement sustainable practices for decades of operations in the province of British Columbia and across Canada. The road to net zero concrete is built on education and awareness and cannot be achieved by industry effort alone. Working with governments at all levels, other industries, and colleagues in the areas of engineering design, architecture, and construction will be essential for success. Acknowledging these interdependencies, the cement and concrete industry are actively collaborating with Innovation, Science, and Economic Development Canada to accelerate the advancement and uptake of lower carbon concrete strategies and technologies across the country. This collaboration is intended to inform sustainable government policy, from regulations and financial programs to supporting the growth of markets for emerging products, all while maintaining the safety, durability, and versatility for which concrete is known. Meaningful action on climate change will require transparent, science-based targets and regular measurement over this decades-long initiative, for which there is no single-source solution. In support of these multifaceted efforts, the Cement Association of Canada and their partners released an industry action plan to net zero in May of 2023. This action plan commits the sector to achieving reductions of 15 million tons of greenhouse gas emissions cumulatively by 2030, representing a 40% decrease against the performance baselines from 2020. The Net Zero Action Plan is focused on 5 key pathways for decarbonization, referred to as the 5 Cs, and address different aspects of the cement and concrete lifecycle, from the extraction of raw materials to the use of recycled concrete in support of circular economy principles. Clinker. Clinker is an intermediate product in the manufacture of cement, which is produced by heating limestone and other select minerals in a cement kiln to temperatures over 1500 degrees Celsius. It is the foundational component of cement that provides its binding properties. It is also the most greenhouse gas intensive component of cement, and by extension, concrete. Key strategies to reduce the carbon intensity of clinker include improved thermal efficiency, carbon capture utilization and storage technologies, and replacing fossil fuels from the manufacturing process with alternative fuels and waste streams. Cement. Cement is the active ingredient in concrete and represents 10 to 15% of a concrete mix by weight. It is manufactured by finely grinding clinker, limestone, and gypsum together. There are, however, many other materials that demonstrate the same glue-like properties of cement, referred to as supplementary cementing materials, and include waste byproducts such as fly ash from the coal industry or granulated blast furnace slag from the steel industry. These SCMs can be used to displace cement or create blended cements that reduce the overall clinker content in the concrete mix. Concrete. Concrete is a composite building material that hardens over time and is comprised of sand and gravel bound together with water, chemical admixtures, and cement. As an essential building material, concrete can be optimized for carbon reductions by making the most efficient use of raw materials utilized, while ensuring the same quality and performance of traditional concretes. In addition to mix optimization, future opportunities to reduce the emissions associated with concrete manufacturing will be focused on the use of clean energy and transportation alternatives. Construction. There are significant opportunities to reduce and avoid the volume of emissions associated with concrete through design and construction practices. Architects, engineers, and the construction industry are all users of concrete products, whether it's in roads, buildings, or bridges, and share in the responsibility of emission reductions. Making the most efficient use of construction materials and examining schedule demands can not only help reduce the carbon intensity of the built environment, but can also eliminate waste and enhance the use of recycled concrete. Carbon uptake. Many may be unaware that concrete naturally sequesters CO2 from the atmosphere, permanently capturing it in a process known as carbon uptake, or recarbonation. This natural carbon uptake effect has been known to occur since the first modern uses of concrete, but has only recently been studied in detail, with quantification efforts currently being examined for better carbon accounting in a North American context. Implementation of the Net Zero Action Plan will be managed on an ongoing basis and will be updated every 5 years, allowing industry to demonstrate clear progress against our targets. Please stay tuned for more on how Concrete BC is working to deliver on this ambitious plan and reach the goal of net zero concrete in collaboration with our partners. Thanks for watching.